In this video, I'm going to go over some examples of forces. Now, in the last video, you learned that forces are caused from an interaction of two objects. And we used this here, the man pushing on the crate, and we were able to look at the interactions of two objects, specifically looking at the forces exerted by objects onto the crate. Now we're actually going to define those forces that we referenced in the previous video. So we had the rightward force of the man onto the crate. Well, this is called the force applied. It's a contact force, and it is typically denoted with a capital F for force and an A. Notice sometimes I will get lazy in class and I will not denote a vector quantity with the arrow over the top. That's okay. Just please know that it is a vector quantity. And the next force we had was the downward force of the earth onto the crate. Okay, so the downward force of the earth, that's the force of gravity. And so it can be denoted in a number of ways as well. Now, typically, the first one that you see here is the one I will most often use in class, but these are all acceptable. And so I want to make sure you know that you can use any of these. I want you to know they exist. I want you to know that if you see a capital W for weight, that is the force of gravity. But the first one is typically the one I'll use in class and on the solution videos, etc. The third force is the upward force of the load on the crate. That is known as force normal. Normal means perpendicular. So it is a perpendicular force exerted on an object by a surface. So if we look here, that would be the perpendicular direction, and it's denoted with the following, okay? So it's always perpendicular to the surface. Now, this can change, but force normal will still be perpendicular to the surface. I'll give you an example at the end of the video. Again, I will typically use this to denote and label force normal, but these are also acceptable. Our fourth force we talked about was the leftward force of the load on the crate, and that was our frictional force. There are two different types of friction, kinetic friction and static friction, and I'll teach you about those in upcoming videos. So let's go ahead and look at some more examples of forces. So here we have the rightward force of the rope onto the box, okay? So we have a rope, we have a contact force here, and I'm again referencing the forces exerted onto the box, and that would be a force to the right of the rope onto the box. And that's known as a tension force. So I'll typically denote with either one of these. I want my students to know all of them that are acceptable. Here we have a spring, and this is the right or leftward force of the spring on the ball. And notice it is changing. We'll talk about the spring force in detail later on in this unit. So depending on if it's in this position, the force is to the right, and now the force is to the left. So that's going to change as a function of the displacement of the spring and some other quantities we'll talk about later on in the course. Then we have this example here, the repulsive force exerted from particle 1 on particle 2. This is the electrostatic force or electric force, and we know that these two positively charged particles will repel one another. That is the electric force. Some other forces here to throw out, just because I want you to know about them, but we will not talk about them very much at all in this course. is the force of air resistance, the drag force, the rightward force exerted by the air onto the plane. So we have drag force. Now, I will throw this out. We will talk about air resistance, and we have already in Kinematics Unit 1. However, unless you are explicitly told there is air resistance, we will neglect it in this course, okay? All right, so another one here, we have the leftward force of the exhaust on the plane. Kind of cool to talk about and think about. That is known as the force of thrust, or the thrust. Here we have the upward force of a fluid onto a ball. That is the buoyancy force. Again, we won't discuss this in this course, but that doesn't mean that I can't teach you guys about these other forces that exist, and there are some more that exist. Now, I want to go over 3 items here before I close this out. So, first, the force of friction is always parallel to the surface of contact. So think back about the man pushing on the crate. The man was pushing to the right. The counter force, which was the force of friction, was pushing back to the left. And right and left were parallel to that surface, i.e. the road. Also, force normal, as I've said, is always going to be perpendicular to the surface of contact. Okay, so perpendicular, these will be denoted as a force that is parallel and a force that is perpendicular, which I've already exposed you to in our studies of kinematics. So let's go ahead now and look at this. This is a ladder leaning up against a wall. So things are a little different here because we have our force of friction actually going up the wall. Well, remember, force of friction is parallel to the surface, and this is the surface of the wall here running vertically. So that should make sense. Force of friction is actually going up the wall. And force normal is actually going out from the wall. But again, it's perpendicular. It is normal to the surface. That's how we can phrase that. It is at a 90-degree angle to the surface here, the wall. So things can change a little bit depending on the coordinate system. All right. Now here we have a contact force. This is the last piece that I want to reference in this video. That these forces result from interatomic electric forces or electrostatic forces. This is important for you to understand that these contact forces result from microscopic interactions. So here we are zoomed in looking at the atomic level of the surface of a desk. Okay, now I am going to place an object down onto the desk. And that object is going to result in an interaction of forces in which the desk will push up onto the object, and the object will push down onto the surface of the desk. Okay, so what's going to happen here is we're going to have a change in the interatomic structure, as you can see here. So these bonds, these electrostatic forces, the same ones we discussed in your studies of chemistry, are now responsible not only for the magnitude of this force, but also the direction of this force. Because of these stresses on the atomic bonds, they're going to exert this upward force onto the object that was placed onto the desk. Okay, so in this video, I've re-emphasized the fact that forces result from an interaction of 2 objects. You've also been exposed to this idea of the microscopic causes and the interatomic electrostatic forces that are responsible for many of these contact forces. And I'll see you guys in class.